everybody. So you should be on page 5 in your note packet today, and we're going to be talking about properties of parallel lines. But let's just do a quick warm-up. I want you guys to, and you should be able to identify the 4 special pairs of angles that we did in section 3.1. So we're going to review them, but what I'd like you to try to do is look at the diagram and see if you can answer numbers 1 through 6. So you're going to go ahead and press pause and then try and fill in the blanks, and then we'll meet up and I'll have the answers out for you, okay? So press pause. All right, you're back. So hopefully you saw that angle 5 and angle 3 were same side interior angles, that angle 8 and angle 2 were alternate exterior angles on the outside of the two lines and on opposite or alternate sides of the transversal. Angle 4 and angle 5 were alternate interior angles. Angle 7 and angle 6 were a pair of corresponding angles, but there's a lot of them. Angle 8 and angle 5 were another set of corresponding angles. And I think I made a dupe because it should be angle 4 and angle 5 are alternate interior angles. All right, so let's look at the next 3. Angle 3 and angle 7, so they are the interior of the two lines and on opposite or alternate sides of the transversal, so those are alternate interior angles. All right, 6 and 1. Well, 6 and 1 are on the outside, so on the exterior of the two lines, on opposite or alternate sides of the transversal, so those are alternate exterior angles. And the last one, 7 and 1, those are the ones we've been working on all year. Those still remain to be our vertical angles. And we know that vertical angles are congruent by the vertical angle theorem. Our little favorite theorem, vertical angle theorem. Okay, so let's review what a postulate is, okay? So first of all, a postulate is something you accept without proof. So I tell you it to be true and you're going to believe me. Accept without proof. So we don't actually have to prove postulates, but we do have to prove theorems. All right, but in order for us to do what we're going to do, we're going to have to use a postulate. So the postulate we're going to use is called the corresponding angle postulate. And since it's a postulate, you are going to accept it to be true without me proving it to you. And the corresponding angle postulate, all the new postulates and theorems we're going to learn, they relate to those two lines when they're cut by a transversal, but these two lines have special relationships when the lines are actually parallel. So the corresponding angle postulate says if two parallel lines, I'm using the symbol, two parallel lines, and remember those two, that looks like an 11 means parallel. Two parallel lines are cut by a transversal, then, so an if-then, corresponding angles are congruent. All right, so if I give you two parallel lines, like two lines like that with a line going through them, and I mark the lines parallel, they have to be marked parallel. Then, let's say 1, 2, 3, 4, 5, 6, 7, and 8. Then angle 1 is congruent to angle 5. Angle 2 is congruent to angle 7 because they're corresponding angles. Angle 3 is congruent to angle 6. And angle 4 is congruent to angle 8. So if two parallel lines are cut by a transversal, here's the transversal T, then corresponding angles are congruent. There's all different kinds of relationships with parallel lines. The corresponding angle postulate is the first. And now we're going to try and prove the corresponding angle theorem. All right, now I gave you a list at the top of the page in your video, but it's not actually in your notes. And so far we have lots of reasons and things that we've looked at that we can use to prove things true. We've got the definition of a midpoint. We've got the definition of an angle bisector. We've got the angle addition postulate, segment addition postulate, linear pair postulate. Vertical angles are congruent. Addition, subtraction, multiplication, division, substitution, transitive, definition of supplementary and complementary angles. We've got the definition of congruence. We've all kinds of things. And now I'm going to add a few more. So we've got the corresponding angle postulate, which I call cap. And now let's look at our next one. So we're given that K, so line K, is parallel to N. So you've got your diagram, and we're going to mark the lines parallel by putting the parallel symbol in that we learned about with parallel. Okay, so we're trying to prove that, and I'm going to put a star, we're trying to prove that angle 1 is congruent to angle 2. Now, the first thing we're going to do is we're going to get our given down, and that, remember, that's like our if. So K is parallel to N, and that's given to us. All right, now we just learned our first postulate that told us if two parallel lines were cut by a transversal, then corresponding angles were congruent. So based on the fact that corresponding angles are congruent, I can say that angle 3 is congruent to angle 2. And the reason would be the corresponding angle postulates. So now I'm going to go ahead and mark those guys congruent because of the corresponding angle postulate. All right, so now I've done everything I can with those parallel lines, but now I've got to use some of my knowledge here. And I'm like, wait a second. I remember that vertical angles, the 1 and 3 are vertical angles. So I'm going to say angle 1 is congruent to angle 3, and that would be the vertical angle theorem, which you guys are really good at this point, right? Okay. All right, now I've got 3 equals 2 and 1 equals 3. So here's a really good place for us to use the transitive property. We can connect 1 and 2 using 3. So angle 1 is congruent to angle 2, and that would be the transitive property. So we just proved that if K and L were parallel, and if 2 parallel lines were cut by a transversal, then 1 equals 2. And what you guys just proved was the alternate interior angle theorem. Okay, what did you just prove? You just proved the alternate interior angle theorem. And so the alternate interior angle theorem says if 2 parallel lines are cut by a transversal, then alternate interior angles are congruent. Wow, that's good. So now I've got corresponding angles are congruent. I've got alternate interior angles are congruent. I wonder what else there is out there. All right, next one. All right, given that K is parallel to N, I'm trying to prove that angle 1, and angle 3, sorry, is supplementary to angle 3. So let's change that. Angle 1 is supplementary to angle 3. Okay, so, I want 1 and 3 to be supplementary. So that means my goal would be to have a statement. The goal would have to say the measure of angle 1 plus the measure of angle 3 equals 180 degrees. So that's what I'm trying to get to. The measure of angle 1 plus the measure of angle 3 equals 180 degrees. Okay, so I start with what I know. And I know that if K is parallel to N. So that's my given. Let me give myself a little bit more room here. All right, so I've got my given. And from the last theorem we just learned, I know that angle 1 is congruent to angle 2. So I'm going to get that based on that given. Angle 1 is congruent to angle 2. And that's the alternate interior angle theorem. The alternate interior angle theorem. Okay, but I somehow need to get 180 into this mix because that's where my goal has to get me, is to 180. So hopefully you're seeing that 3 and 2 form a linear pair. So I'm going to say that angle 3 plus angle 2, the measure of angle 3 plus the measure of angle 2 equals 180 degrees, and that's the linear pair postulate. Okay, so I've got the 180 in it, but I need it to be 1 and 3, not 3 and 2. Well, didn't I say that 1 was congruent to 2? So now I can take my 1, I can plug it in for 2 because of substitution. So I can say the measure of angle 3 plus the measure of angle 1 equals 180 by substitution. Okay, so am I ready to make the final statement? Did I reach my goal? I got to my goal, and if 3 and 1 equal 180, well then we can say that angle 1 is supplementary to angle 3. And that would be the definition of supplementary angles. All right, so if I've gone fast, the great thing about the flipped classroom is that you can go back and review it. So if you need to, it's been, I think 10 minutes this video, so not too long. I want you to go back and review any part that you needed to. So always remember that you can do that. All right, so let's just figure out what we just proved. What you just proved is that if 2 parallel lines are cut by a transversal, 1 and 3 are same side interior angles, and we just proved that they are supplementary. And that's exactly what the theorem says. If 2 parallel lines are cut by a transversal, then same side, and look what I'm abbreviating, same side interior angles are congruent. Okay, so the last one, I'm actually not going to prove it. We're going to do it in class tomorrow, but I'm just going to give you the theorem, the alternate exterior angle theorem. So if 2 parallel lines are cut by a transversal, then alternate interior angles, are congruent. On the last one, I actually just realized I made a mistake. It should have been same side interior angles are supplementary. I think I said supplementary and I wrote congruent. Sorry, are supplementary. Sorry, Coach Fred made a mistake. All right, let's just recap. Okay, so the quick review. If 2 parallel lines are cut by a transversal, then corresponding angles are congruent, which just means they're equal. Alternate interior angles are also congruent, which just means equal. Alternate exterior angles are congruent, which just means equal. And same side interior angles are supplementary, which means they add to 180. And that's basically what happens when we have 2 parallel lines cut by a transversal. All right, guys, so we'll review tomorrow and practice for the next couple of days on this, okay, in class. Thanks so much.